good to see so many of the Matrix panel members here today, and thanks to those of you who also travelled over from the mainland today. You've given us plenty of support this last 6 months, and I'd like to genuinely thank you for that. And as I also look around the room and see the fundamental sustainable energy community from Northern Ireland all sort of well turned out, and thank you for coming. And hopefully you were aware of the fact that Matrix was carrying out this report over the last 6 months. And hopefully you were also able to communicate with the panel members and have your views and made known to us, and that those views will have been taken into account in the final report. I'll say a little bit towards the end about where we go next and what we do next, and I would like you just to remember that we need your input all the way through this process. So make sure you know who is on the panel going forward, and please communicate with those on a regular basis. I'd like to thank NISP Connect and the Institution of Engineering and Technology for sharing the event today. It's always good to collaborate. Now, the Matrix organisation from within the DETI, Department of Enterprise, Trade and Investment, has been going for quite a few years. They've had a number of topics that they've produced reports on in the past. And it was only last year that the DETI Minister, Arlene Foster, tasked the Matrix organisation with identifying how to grow the Northern Ireland economy through the development of sustainable energy technologies. This is all about economic growth, trying to provide jobs and prosperity to Northern Ireland through whatever skills and talents and track record of the companies and academic institutions that exist here. So it was interesting that it took quite a long time for sustainable energy to appear on the horizon. And I'm glad to say that the process has been very fulfilling for everyone involved. We convened the panel with 15 different industry experts and academics from a range of sustainable energy backgrounds. I mean, I think every technology you can think of was represented. And we came together over a 6-month period to map and assess the current capabilities of the sustainable energy technology sector in Northern Ireland, and to identify the future global opportunities available to the region. It is a global problem of climate change and depleted fossil fuel reserves, so the solutions really are global as well. And if we can develop technologies and techniques and services here which work here, then there ought to be a very good correlation with seeing them work the rest of the world. And that was the thrust of what we were doing. And whilst we found plenty of good examples of work already underway, we concluded that there was a particular set of circumstances relating to the electrical grid network in Northern Ireland that were causing a challenge here for continued deployment of sustainable energy capacity. And it's something which has happened in other parts of the world where there's high penetrations of intermittent renewables, but it's something which is now definitely happening here. And we recognise that it hasn't yet happened in England, Scotland and Wales or in the Republic of Ireland to the same extent. So that therefore we've got a little bit of a march ahead of the game with this problem. And if we can develop those goods and services and economic activity and cause some partial solutions to these things, then whenever those problems begin to occur in other regions, then we're well placed to exploit that economically. So what is the challenge that we were talking about? And it comes down really to the fact that Northern Ireland is a very, very windy place where the economics of developing wind power is very attractive here. There are incentives to get us involved with development of projects through the renewable obligation. There's very ambitious targets of 40% of consumed electricity to come from renewables by 2020. These are all great things. The difficulty, though, arises because we've got a very small population, and the electrical load, therefore, is low. And certainly at night times, in the summer, we've got very low levels indeed. And if you try to run all of these wind turbines at such times, then you just simply increase the voltage on the system beyond the statutory limits, and that wouldn't do anybody any good. So the machines generally then have to be curtailed and shut down. And that causes a very specific problem on trying to finance a new renewable energy project, because if you don't have certainty on what your income streams are going to be, and it's uncertain enough with wind, then this lack of knowledge on what your income is going to be is crippling the ongoing prospects of building out the targets that we need. So Tom's going to say probably a bit more about curtailment from the horse's mouth, as it were, so I'll not say too much more about it. But another big problem is that the grid system here was designed with big central power stations in the east of the province, feeding energy out into increasingly thin wires and lower voltage networks towards the west. And where we find most of these wind farms being constructed is in the west, where the grid isn't strong enough to take all of that power and where the load doesn't exist. So we're faced now with having to upgrade those lines, to put thicker conductors in, to increase the voltage of some of the circuits, to put extra circuits in, all of which costs quite a lot of money, and anything between a couple of £100 million or £1 billion, depending on who you listen to. And that is a cost which is allowed to be passed through to electricity consumers, so that makes our competitiveness on electricity prices worse. So it's not something that people particularly want to have to do, but in order to meet the targets as it stands today, that's the only thing which can be done. So I suppose all of us people from the sustainable energy community said, well, we're all suffering the same problem here, whether it's a wind turbine or a tidal mill or an anaerobic digestion plant. If we can't get cost-effective grid connections in a timely fashion, then what's the point? So whilst we do continue with developing each of these individual technologies and to some extent trying to amalgamate them into systems, certainly where you're sharing heat balances and things, we decided to focus for the purpose of this report on that big problem and opportunity of using the existing grid more intelligently so that we can defer reinforcement or avoid reinforcement, save all of those costs or some of those costs. And the realization was that there's a few techniques that can be brought to bear to do that. We collectively decided to call that the intelligent energy systems. So it consists really of three particular areas. The first one is interconnection. I mean, our history is we've had this small, isolated grid. We've always had interconnectors with the Republic of Ireland for system support and frequency support and such things, but very little energy actually traded backwards and forwards. We then had the interconnector through the Moyle to Scotland, which was a big step forward and sort of utilising the power that interconnection has to make us more secure. But we now need to look to the north-south interconnector to be constructed and for an east-west corridor from the Republic of Ireland over to the mainland to be fully accessible from us, so that whenever it's windy in Northern Ireland, we do have markets outside the province that we can sell some power to. Now, it's limited because when it's windy here, it's also windy in the Republic and in Wales. It's not geographically massive distances, but certainly it has to be there, and we have to make as much use of that as possible. The second category really is energy storage. And this is a fairly new phenomenon. It's been around a long time in the form of pumped hydro, and pumped hydro remains today the cheapest form of energy storage and of bulk electricity. It has a sort of downside in being geographically constrained. If you've got lovely mountains, then you've got great opportunity. If you've got flat terrain, you've got virtually no chance. So it's the cheapest, it's the one that we've got to try and emulate, and I think from some of the work that we've certainly done now at B9, discovered that isothermal compressed air energy storage holds the promise of being as cost effective with as high return trip electrical efficiencies, but with the additional benefit of being able to be located almost anywhere on the grid, because storage does need to be deployed strategically at certain locations on the grid in order for it to, its benefits to be maximized. That's on a very large scale. The salt caverns at Millbrook and Larne would be such a location for 100 megawatt plus facilities for energy storage, where you're storing up when it's windy and you're delivering back to the grid at peak times in the evening, sort of avoiding the use of open cycle gas turbines and things like that. But there's also initiatives on the smaller end of energy storage, which we're seeing now, where these devices can be deployed on weak 11 kV networks to provide some load at the time when it's windy, to allow cost-effective grid connections for small single wind turbines at the 250 kilowatt level, for instance. And in looking at the different battery technologies available that would fit the bill for these small-scale systems, and you're talking 50 kilowatts up to 100, 200 kilowatts maybe at the most, we concluded that with the advent of electric vehicles coming along in their tens of thousands, where the range of those vehicles is very critical to the owner, there will come a point in time before the end of the life of the electric vehicle that its battery is underperforming. And you would simply take the battery out of the car and put a better one in, a newer one. And that old second-hand battery, though, is still perfectly good for our distributed electrical network use. So we would have a second life of these former traction batteries and take them all. And there's so many of these available from the automotive sector that we really don't need to look beyond that. So quite an exciting series of dots we're joining up to get that supply chain organized. And of course, when they really do have such a low performance that they're then no use to us, then they go back for reprocessing. The third category, which is probably more immediate and more fundamental, is that whole subject of demand-side management. That if the problem is there's not enough load when it's windy, well, why don't we just put more load on the system then? And it's a few things need to be said about that load. It has to be remotely controllable. It's not something which you must rely on the members of the public to do for you, because they're unreliable. You have to be able to control this stuff remotely. And we need an awful lot of it. And earlier this week was launched the Dimplex Quantum product line, which is hot water cylinders and controllable storage heaters for houses, where the charging up of those devices using electricity is switched remotely, unbeknownst to the house owner. And if we were to put thousands of these devices out there and control them in some concert way, then we can add load to the system when the system needs load. Interestingly, up in the Orkney Islands, there's been a good situation arising, which is a microcosm of what we're now experiencing in Northern Ireland. And they had an oversupply of wind, not enough load, and where they were needing to build new interconnectors with the mainland of Scotland. And in order to avoid the upgrading cost, they introduced a contractual method whereby the utility can pay for load on demand. So if you've got the load available, you can put it on the system when they want you to, then they'll pay you for that. So in that sort of arbitrage arrangement with energy storage where you, the conventional idea is that you buy electricity when it's at a low price and you sell it when it's a high price. And when you run the models, you always find you struggle to make enough money to be viable. In this case, you don't actually have to buy your electricity. You sell load at that time, and it transforms the economic proposition. So we're looking very closely at that as a precursor. There's a very serious piece of work, and could we use that here as our sort of foundation for the next step of development? I mentioned as well the electric vehicle charging. There'll be tens of thousands of these vehicles on the road. It could happen very quickly if the oil price rockets up, as it always is at risk of doing. And you may think that that's a bit of a difficult nut to crack, but I mean, you probably only sit in your electric vehicle 2 hours a day at most. So for 22 hours a day, provided it's plugged into the grid and into the internet, somebody out there can be charging it up for you, making best use of whatever wind, tidal, or other intermittent sources of renewables there are. Electrolysis is always there for production of hydrogen and enriching natural gas networks, converting the hydrogen into ammonia, for instance, for making fertilizers that would avoid the importing of chemical fertilizers. It would improve the environmental carbon footprint of our farm produce. The same ammonia can be liquefied and used as fuel in tractors so that we wouldn't have to buy as much diesel from outside our borders. There's quite a few things that electrical load can be brought to do. So that real-time monitoring and control that's required to balance generation and load on the system using these tools has been described as intelligent energy systems. And this became the core opportunity identified by the panel. The problem is common to all grid-connected renewables, and solving it here means we can export goods and services to other UK regions and beyond, and as and when they encounter the problem. 2016 in GB sees the retirement of some of the baseload nuclear power stations. They haven't managed to have the replacement plan being delivered in time, so there's going to be a shortfall of delivered energy. Similarly with old coal-fired stations retiring. And at the same time, you will begin to see huge numbers of offshore wind farms bringing intermittent renewables onto their systems. So it's fairly easy to predict, we think, that curtailment of wind farms in GB will probably happen at or around that time. I just wanted to say a few words about some of the initiatives that have already been happening here. This is known to Matrix, and Matrix certainly supports these initiatives. There's 2 collaborative networks which have been formed. The first one is called SENSE, and that stands for Smart Energy Storage. It consists of quite a few different companies that represent the supply chain for energy storage equipment. So it's the interties, it's the equipment itself, it's component manufacture, that sort of thing. And also the end users of energy storage, which would be wind farm developers, single turbine developers, utilities. And these people are all sitting in a room now on a regular basis to discuss how this technology can be brought to bear. So, again, look out for that one if you're interested in joining, then let me know. And another related one, more on the demand side, is called 6X DSU. The 6X is 6 multiplied by, and DSU is demand side unit. In the single electricity market legislation, which is now coming in for the island of Ireland, there is reference to demand side units being established, either unilaterally or as an aggregated organisation. And this allows third-party companies to access the 11 kV networks in particular, and to manage the loads and the generation on those systems to try and find some sort of balance. They would interface with the system operator with regard to dispatch, so bring load on, take load off, bring generation on, bring generation off. And the 6X DSU intends to set up 6 of these DSU models, one for each of the of the counties in Northern Ireland. Each one at its core would be similar and using the same techniques and equipment, but the actual flavour of each one of them will be slightly different. For instance, the one at Ballycastle will endeavour to modulate the variable output from the tidal farms on the north coast and use as much of that energy in the Ballycastle region without needing to export down the lines at peak tide, which means you can perhaps avoid some of the cost of upgrading those lines. Another one for central Belfast would look at what you do when you're close to the large load centres. Interestingly, they appear to lend themselves with being community-led projects, because you've got a whole plethora of farmers and landowners with single turbines, AD plants, you've got digger drivers and construction people and operation and maintenance people, all living in the rural communities who would like to get involved. And what we hope to see is that each one of these DSUs would have a community element, and that those 6 communities would then join force to do their lobbying, for want of a better word, and applying for grants en masse and things. So it focuses all the attention, and Matrix will certainly be following the progress with that initiative. And indeed, collaborative networks are very relevant for the way we see Matrix going forward itself, because the report production process was episodic. It had a beginning, a middle, and now today is at the end of that process. And rather than have the recommendations that we arrived at just put on a shelf and forgotten about, we've decided to try and keep this organisation going. And the way to fund that, both the sort of secretarial effort that we need and the consultancy effort that we need, Invest Northern Ireland are now seeking to further support this industry-led collaborative project aligned to thematic priorities. Sorry, I think I'm reading out the wrong bit there. The DETI team responsible for supporting Matrix are working closely with the Centre for Advanced Sustainable Energy, CASE, that's Sam McCluskey, to develop an application to Invest Northern Ireland's Collaborative Network programme. The purpose of the network support is to develop a comprehensive 3-year business plan which will detail all the potential projects within the intelligent energy arena for Northern Ireland. It will scope potential funding streams for these projects, because there's lots of different calls from national government departments and more local or regional sources that we can collectively apply to. And design a structure for an implementation and delivery team to drive the report recommendations. This opportunity would be open for anyone with an interest in this area, so please speak to Sam McCluskey at CASE for further information. Part as well of this initiative that we've created is that I&I does want to now have a call for other collaborative networks to be formed in this space. So I&I are seeking further support to further support industry-led collaborative projects aligned to the thematic priorities as detailed within the Matrix Sustainable Energy Report. Now, the executive summaries will be ready for you today before you leave, and in the full report, I believe there might be a few of those around as well. So if you read that and you discover something which you think would lend itself with a collaborative network that you would like to be forming or to join in with, then for further information about how you do that, you would contact I&I's collaborative network team, headed up by Linda Jameson, and that can be found at www.investni.com/sustainable energy. There is another aspect to this which was very important for us, and that is that whilst Matrix is formed from DETI and has enterprise, and DETI also has the energy agenda, that's all well and good, but there are other departments which are now keen on adopting aspects of sustainable energy into their policies. The two in particular are Department of Agriculture and Rural Development, which is the custodian of 10 million tonnes of animal slurries, for instance, which at the moment is a nutrient balance issue management situation for them in their current legislation. But we see that as fuel for anaerobic digesters. So to try and have cross-departmental cooperation where they now open up themselves to be more amenable to energy derived from this material is something which we're having discussions about. There is a need for about 150 farm-scale AD plants in Northern Ireland to treat all that organic waste and extract the energy. And the digestate can still go back to land. It actually does a better job because the nitrate's in a better form. And the grass production rate increases. So we will have within our matrix structure some sort of arrangement whereby government departments agree to work together on some of these fronts. Similarly with the Department of Environment, which is there to look at the municipal waste sources.